looks like it's time to get started. So this is the second set of advanced complex number problems from the IIT JEE Indian Institute of Technology Joint Entrance Exam. And the references again are the Pearson Guide to IIT JEE Mathematics, 3rd edition, and a problem from an actual IIT JEE exam. Again, the whole point of all these problems is to illustrate the fact that you must be comfortable with moving not only the properties of complex numbers, but you should be very comfortable in being able to, so the concept, if you will, the crux, is a complex number can be written in standard form, the same complex number in polar form, and also in exponential form, e to the I theta or e to the j theta, okay? So you should be able to move very comfortably between all these forms, okay? And these are challenging problems to motivate you, but you need to be able to do this to understand phasors, okay? But let's get started. So the first problem is, so let me again rewrite this. So let's start solving this. And again, there are many ways to solve this problem. Some of them, like in this case, in my opinion, it's so simple that you can just start from the question and go to the answer. For example, for the second one, you can actually just try to plug in and figure out which Z works, but not recommended, right? That is, in the sense, you do it systematically and you try to appreciate the beauty of the problem by thinking outside the box and applying sound mathematical principles. So here, when you get started with this problem, so it'll be like, what is square root of I minus square root of negative I equal to? You can be like, wait a minute, I know I or j is defined as square root of negative 1. How do I simplify square root of I? And in your head, you should start thinking, wait a minute, this is not the only way to write I. That is, I can write a complex number in different forms. I'm actually going to use the exponential form. That is, I in exponential form can be written as e to the, I'm going to use I again, pi over 2, 1/2. Yeah? So in other words, you should know cold that I, the complex number I, if I just plot it on the Argand plane, this is I. Okay? So in other words, e to the I pi over 2, just cosine pi over 2 plus I sin pi over 2, cosine pi over 2 is 0, sin pi over 2 is 1, but whatever, right? You should just know this down cold. And this guy is e to the minus I pi over 2, 1/2. So now you can be like, aha, this is e to the I pi over 4 minus e to the minus I pi over 4. And this, you should know Euler's formula that e to the I theta minus e to the minus I theta over 2I is sine of theta, okay? So in other words, this is equal to 2I sine of pi over 4, okay? So this is 2I sine of pi over 4 is 1 over square root of 2. And if you multiply and divide by square root of 2, I'll get square root of 2I. And the reason why I'm doing that is I believe that there is, it's A. So square root of 2I is up here, okay? So in other words, the answer is A, or the solution is A, square root of 2I, okay? And it turns out we can actually we can try to check this on our calculators, yeah? So here's our calculator. Let's turn this guy on. And I don't know why it's so dark. So let me reset the calculator. Let me try turning it on again. Okay, that's not working. Exit without saving state. Let me see. Sorry about this. Let me go to the desktop. That's where I believe I saved the emulator. It's fine I'm taking time because I have still a lot of time for the 7-minute break. So, there. Okay. So now what I want to do is I want to type in, let's see, second square root of, escape, second I, close parentheses, minus, I believe it was a minus, yep. Second square root of negative I, then enter, square root of 2I, what do you know, right? But again, if I'd given this problem to you on the exam, I would expect you, not only me, any sane instructor would expect you to show work. Okay, how did you get this? And well, this doesn't really help. It's a testament to the people who designed this that, well, it's not really a testament, like in the sense, this is not that difficult in my opinion. Okay, that's why I'm doing this as the first problem. As long as you're comfortable with moving between, and you should be, that I can be written in exponential form like this, and then simplifying, and then from Euler's formula, I can rewrite this in terms of sine, and then sine of pi over 4, that's the third thing. Sine of pi over 4 is 1 over square root of 2, sine of 45 degrees, and you should know all this. Okay, the people who are taking 2060 at MSOE should ideally be sophomores, second year students in engineering, right? If you don't know that sine of pi over 4, first of all, you should know that pi over 4 is 45 degrees, okay? If you don't know that, well, just go back and brush up on your trigonometry or learn it. Okay, it's okay if you don't know. It is not okay if you don't know and you don't learn it. You don't make an effort to learn it. Remember, motivation, mindfulness, and practice. Okay. All right, so that's the first problem. Now let's look at the second one. Is it time to take a break? Yeah, I'll take like a little break and then I'll be back to quote Arnold Schwarzenegger. Okay, continuing, here's the second problem. I've copied and pasted it. The complex number which satisfies the equation blah is what? Well, what you can do again is, well, you got to figure out what form of the complex number you need to choose. So let's choose, let me call Z is A plus IB standard form. Why did I choose standard form? Because I'm adding complex numbers. When you're adding complex numbers, standard form is the most ideal. Okay. So Z equals A plus IB. This implies that Z plus, so I'm just going to solve this. That is equals 0. Implies that on the left hand side, if I get a complex number in standard form, if I equate this, so this is 0 plus 0i. So if I equate the real and imaginary parts to 0, I should be able to get what Z is. Let's see. So Z is A plus IB plus square root of 2 magnitude of 1 plus Z is 1 plus A plus IB magnitude plus I equals 0. And this is pretty trivial actually. So this is A plus IB plus square root of 2. And well, the magnitude of this guy is square root of the sum of the real part squared plus the imaginary part squared equals 0. Put parentheses around this there. Okay, now I multiply this out, so this implies that I have A plus, let me see, square root of 2 times 1 plus A squared. Just be careful, plus 2B squared. Like, you got to multiply the 2 out into the square root. This is probably a common mistake with students make. You just forget that it's 2 times 1 plus A squared plus 2B squared. Just be careful, right? Be mindful. Plus I times B plus 1 equals 0. Where did I get the B from here? Okay. Now again, this is very nice. Therefore, we have B plus 1 is 0. So B is immediately negative 1. Okay. So let's go back to our choices and see if we can actually eliminate some of them. So B is negative 1. So then C and D are out. Okay, but that doesn't tell us what A is. A is either plus 2 or negative 2. Well, it should not be too hard. And A plus square root of 2, the real part is also 0. Let me do this. 0i here, 0i here, 0i here. Yeah, just to be consistent. 1 plus A the whole squared plus B is negative 1. So let me plug that in. Plus 2 equals 0. Yeah. So this implies that A squared, if I just do all these simplifications, is A plus 1 the whole squared plus 2. This is just algebra now. Okay. So this is, let's see. So this is A squared equals, well, it's algebra. 2A squared plus 2 plus 4A plus 2. And then, yeah, it's just A plus 1 the whole square multiplied by 2. And if you just do all this, you get A squared plus 4A plus 4 equals 0. This implies that A plus 2 the whole squared equals 0 and A is negative 2. Therefore, the answer is, I believe, B. Okay. B minus 2 minus I is your Z. And if you want, you can actually, on a calculator, I'm not going to do this, and you should. You can just plug in negative 2 minus I into this equation and ask it to simplify it and see if it's equal to 0. Pretty sure it will be. But there is your second problem. We are actually only at the 10-minute mark. Remember, I try to make these videos 21 minutes long, but it's good in the sense I have a lot of time for the next problem. So let me take a break right now. Pause recording and I'll be back. All right, continuing. So this is a very, in my opinion, a nice problem. It took me around 20 minutes to solve this problem. But before we get started with the solution, again, you should really take a bird's eye view of the problem, okay? I mean, like the other problems, you can try figuring out which one of these choices. And in this problem, actually, more than one choice works, okay? So it's actually multiple. It's not only one choice for this, unlike the other two problems. So instead of plugging in and solving it, it's not a very elegant way to do this. We will try to interpret the question in terms of what the answer form is, and also remembering this idea, okay? But as you will go through the solution, you'll see that's basically what this problem is. Are you very comfortable in moving between these forms, and are you comfortable in the properties of complex numbers, okay? So let's look at this. So Z1 and Z2 be two distinct complex numbers. So what does that mean? So Z1 is not equal to Z2. And let Z equals blah for some real number T. So T is between 0 and 1. Argument of W denotes the principal argument of a non-zero complex number W. And I've discussed what the principal argument is. Basically, it's in the 2060 lectures, but if you didn't know, let's say the complex number is in the first quadrant. This is the principal argument theta. Let me just write it out. It's between minus pi and pi. This is just an illustration of a complex number Z being in the first quadrant denoted by point P. And this question, you don't know where the complex number is. Okay, so it's just an illustration of what the principal argument is. But having drawn this, let's see. We talked about the principal argument. We have taken care of the fact that Z1 and Z2 are distinct. Let's look at the answer choices. It's asking us the magnitude and the argument of a linear combination of Z, Z1, and Z2. So then what we got to do is let's see if we can rewrite this expression in a form that is conducive to pointing out what the answers could be. So let's see. It's given that Z is 1 minus T, Z1 plus T, Z2. T is what? A real number, and T belongs the open interval 0, 1. Open interval means T cannot be equal to 0, T cannot be equal to 1. Okay. All right. So now looking at the answers, we can see that we want, or looking at the choices, I'm sorry, Z minus Z1, Z minus Z2. So let's try to get Z minus Z1 and Z minus Z2 from this expression. That's going to be our goal. Let's see if we can even do that. So Z equals, so first I'm going to try to get Z minus Z1. Z1 minus TZ1 plus TZ2. And wait a minute. I can simply get this as Z minus Z1 equals minus T times Z1 minus Z2. That's awesome, right? I'm going to box these, but remember, these are not my final answers. Okay, actually, let me do this. Since I'm going to box my final answers, let me save this first. Then what I'm going to do is I'm just going to highlight, and I'll just, I don't know, like, do that. Saying that's important. Hey, wait a minute, I can just number the equation. What am I doing? I'm sorry. Let's call this equation 1. Okay. So I got Z minus Z1. Let me get Z minus Z2 from here. So again, Z is Z1 minus TZ2. Oops, I messed that up. I've been thinking one step ahead. Okay. All right. So there is no Z2 here. But let me do this. Z minus TZ here. So let me do Z minus Z2 on the left-hand side. So I've subtracted Z2. I have to add Z2, so I don't change the equation. plus tz2. And then let me take this negative plus z2 to the other side. What do I get? I get, let me see, z1 factors out 1 minus t plus tz2 minus z2. This is very interesting. So if I do z1, 1 minus t, if I take minus z2, I get 1 minus t. So in other words, my z minus z2 is z1 minus z2 times 1 minus t. So this is equation 2. Okay, so let me zoom out. Actually, I don't have to zoom out. No, I have to zoom out. Sorry, 5%. So how does this even help us? So here are the two expressions, z minus z1 and z minus z2. How does this even help us solve this? Wait a minute. These are complex numbers. Well, t is real, but it's a complex number with zero imaginary part. So what I can do is I can look at the magnitude and phase of magnitude and argument, to use the notation in the question, the magnitude and the argument of these two expressions. And Viola, I should be able to intuitively figure out which of the choices A, B, D are correct. C seems like it requires a little bit of work. And this notation, if you're not familiar with, is called as a determinant. I'll address this shortly. But my claim is, just thinking, I should be able to figure out which of the choices A, B, D are appropriate based on looking at the magnitude and argument of these expressions. So let's look at, first of all, when you can look at either magnitude or argument, let me just look at the argument. So consider the arguments of 1 and 2. Okay. So basically, to consider the arguments of 1 and 2, we need to write 1 and 2 in, let me do exponential form. I can do it in polar form, but I'm just going to do it in exponential form. So on the left hand side, I have z minus z1, some magnitude, e to the j at an angle, the argument of z minus z1, whatever that is. Okay. Now, negative t can be written as t e to the j pi. Yes? Times magnitude of z1 minus z2 e to the j, the angle of the complex number z1 minus z2. Okay? But then, if these two complex numbers are equal, this implies, then let's see, do you want to do the argument of 2? Let's leave out the argument of 2. So let's just look at, I claim that just doing this, we can just consider arguments of 1 and 2. 2 is not necessary, okay? Not necessary. So actually, let me do this. Let me just strike this out. So we don't need that, okay? I claim. So keeping on going. Okay, I have only like 30 seconds till I hit 21 minutes, so I'm going to go over for this lecture. That's fine. Such a beautiful problem. We got to do justice to this problem. So therefore, if you call this equation 3, so 3 implies that the argument of z minus z1, the angle, must be equal, the argument on the left-hand side, must be equal to the angle on the right-hand side. But the angle on the right-hand side is pi plus the argument of z1 minus z2. Well, how does adding pi change this? Well, I claim, let's do this. If you look at the choices, correct? So let me zoom out even more. Let's see if I can fit the entire thing. 50%. Yes, I can. So you can notice that this last choice seems interesting. Argument of z minus z1, which is what I have on the left-hand side, equals argument of z2 minus z1. Here I have pi plus argument of z1 minus z2. Well, is pi plus argument of z1 minus z2 argument of z2 minus z1? Let's see. That is, does adding pi flip this here? Well, I know that negative z1 minus z2 complex number is z2 minus z1. But if I write this in polar form, negative 1 is e to the j pi times this guy is, I'm going to write it in standard form because I don't have room, z2 minus z1. But you can see that from this little rough work here, adding pi to z1 minus z2, the argument is the same as the argument of z2 minus z1. So this is basically argument of z2 minus z1. Now, if you don't see this, I recommend you write this, in exponential form like I've done up here. Oh, up here, and then actually go through this. But basically, therefore, 4 implies choice D is one of them. And this 4 also implies, I just realized it, choice C cannot be true. Why? The only way, not choice C, I'm sorry, choice B cannot be true. Why can't choice B be true? Because the only way argument of Z minus Z1 equals argument of Z minus Z1 equals argument of Z2 minus Z1. Now, if argument of Z minus Z1 equals argument of Z minus Z2, by what we just proved, this implies that Z1 has to be equal to Z2. That's the only way this is true. Yes? And that is not the case. Okay? So you can actually figure out that choice B is not true because of choice D. Okay? If you don't believe me, think about it for a few minutes, right? Now, what about A and C? Well, for part A, and turns out for part C, we need, the magnitudes, okay? So, let's look at the magnitudes. So let's consider the magnitude of equation. Looks like mine crashed. So looks like I have to pause the lecture. Okay, continuing. If you look at the magnitude. Oh, before we leave, one note. Why is choice B? I told you that Z1, this implies that Z1 is equal to Z2 if choice B were true, and we know that Z1 and Z2 are distinct. Well, quickly, as a hint, if you don't realize why that is true from here, well, take a glance at equation 2. All right, so basically with 1 and 2, if you look at the arguments, you can figure out that B is not true. So anyway, let's look at the magnitudes of equation 1 and equation 2. So magnitude of equation 1 is what? On the left hand side, I have magnitude of Z minus Z1. On the right hand side, I have the magnitude of the product of two complex numbers, which is the product of the individual magnitudes. Therefore, I claim that the magnitude of 1 is going to be, implies Z minus Z1. I remember the equation is T times Z1, magnitude of Z1 minus Z2. Similarly, magnitude of 2 is going to be magnitude of the left, magnitude of the right. So it's going to be magnitude of Z minus Z2 is the magnitude on the right is this guy. But if I call this equation 5 and equation 6, I claim that if I simply add 5 and 6, I get, why am I adding this? Well, look at choice A. The left-hand side of choice A is exactly the sum of these two left-hand sides. Just take a look. There it is. Well, is the right-hand side equal to magnitude of Z1 minus Z2? Let's see. This is going to be magnitude of Z1 minus Z2 times T plus 1 minus T, and Viola it is. Therefore, this implies that choice A is also correct. Okay? Now, what about choice B? For figuring out if choice B is correct or not, you need to understand, it's not that difficult, what this concept of determinants. Okay? So what does this symbol mean? That symbol simply means, note that the determinant of AB, CD is simply AD minus BC. Well, using that definition, therefore, this is determinant, of these guys, conjugates, and it looks complicated, but it's not. Again, if you understand the properties of complex numbers as you have it down cold, is equal to 0. Is this true? So if you just apply this definition here, Z minus Z1, Z2 conjugate minus Z1 conjugate, minus Z conjugate, a lot of Z's and Z1s and conjugates, just be careful of keeping track of them, equals 0, okay? Now what I want to do is, let's see, what can I do? I can expand this out, but let me see. Can I play some tricks? I do know that Z minus Z1, I believe, can be written in terms of Z2 minus Z1 based on my equations. Yep, right there, based on my equation 1. So this is from 1. I can write Z minus Z1. I remember this as minus T times Z1 minus Z2, Z2 conjugate minus Z1 conjugate, minus Z conjugate minus Z1 conjugate. Let's see, Z2 minus Z1 equals 0, which implies that, let's see, so I can factor out now as Z2 minus Z1, so that means this negative sign will get absorbed. I get T times Z2 minus Z1, the whole conjugate. You should know that A conjugate minus B, A conjugate plus or minus B conjugate is A plus or minus B, the whole conjugate, minus Z minus Z1 conjugate equals 0. Yeah? Now, the product of these two complex numbers equals 0 implies that Z2 minus Z1 equals 0 or Z2 is equal to Z1. Again, that is not true because it's given that Z2 and Z1 are unique. Therefore, this implies that T times Z2 minus Z1 the whole conjugate equals Z minus Z1 the whole conjugate. If I conjugate both sides of this equation, I basically get, well, the conjugate of the product is the product of the individual conjugates. Again, properties of complex numbers. The conjugate of T, which is the real number, is itself. I basically get a true statement. I mean, is this true? Yes, it is. This is our property equation 1. Okay? I think that's what it is. Yeah, here it is. So, I mean, there's a negative sign difference here, but you can factor out a negative sign. You basically get back equation 1. So you get a true statement. Okay? Therefore, choice C is also true. So the answer to this problem, therefore the solution, is choices A, C, and D. D is the only one that's not applicable.